Thanks everyone for having us here. My name is Ray. I'm a developer advocate for the Google Cloud Platform. I like to bring technology to developers all over the world, and I work on a Spring Cloud GCP project as well. If you'd like to give it a try, let me know. The best way to find me is on Twitter @Satanism. Okay.
I'm Ludovic Champenois. I'm an engineer working on App Engine. I work in San Francisco, and I've been bugged by Ray for the last maybe 2-3 years, because first of all, we were only Java 7, and Spring Boot did not really work well on App Engine. So now we're going to show it works.
Yeah. All right. Very cool. So the first thing that we're going to talk about is the JHipster Kubernetes generator. I submitted the initial feature request, and also I started to work on the initial PR. I cannot say I finished it, even though it's merged, partially because I never went back to fix the formatting on the JavaScript. If I recall correctly, somebody else did all the work. So thank you very much. Now, so the Kubernetes generator has been around since 2016. And since then, it's been worked on by the community, and a lot more features are being added. But I just want to recognize, I know that Pierre actually helped me quite a bit, and also Pascal helped on this issue as well, so that we can actually generate the deployment files for Kubernetes. So you can actually deploy JHipster, monolith, and microservices into Kubernetes. Since the initial contribution, I haven't had the chance to check out what is new. And then I found out, oh my goodness, there are so many new things. You can actually deploy JHipster registry. You can deploy Prometheus and Grafana for monitoring. And also initially, we started off with just MySQL. And now you can use Couchbase, Postgres, Elasticsearch, Kafka, and a bunch of other things. So thanks for everyone who's been contributing to it. Now, JHipster had traditionally been created using the Netflix OS stack. What that means is that we have the gateway, which is not just the front end, but also with the Zool gateway, where we're proxying the request. So all the calls to the microservices have to go through the gateway in order for it to get routed to the backends, right? And also that JHipster was using, say, Ribbon for client-side load balancing. And in order to use client-side load balancing, you need to be able to find backends from a service registry. And that's where JHipster registry comes in, and you use either Eureka or maybe you use Console or something else, right? So you need to deploy that component as well. In a microservices environment, you also need to be resilient to the network transactions, right? Every time you make a call, the network may actually fail or the backend may not be there. So you have to be resilient. And so in JHipster, they also use Spring Boot and Netflix OSS by using Hystrix. That's how they implemented circuit breaking and retries, and so on and so forth, right? There are a lot of the cross-cutting concerns that microservices architecture have to consider and solve. And traditionally, all of these components are put into the application directly. And so a microservice not only has the business logic, it also has a lot of these other logic that deals with the cross-cutting concerns. And so a microservice might become a microservice, a bigger service, right? If you look at the jar files, it's actually quite large with all of these dependencies. Now, when I was looking into this recently, I thought, hey, is there a way for us to use more of Kubernetes natively? Right? So for example, Kubernetes has service discovery built in, it has load balancing built in, and we can actually use some of these features directly, potentially without having to add additional components, because every box that we add, we have to manage it somehow, right? So with the one of the patch that got in, and it is in JHipster 5, when you create a new microservice or gateway with no service discovery, and if you generate Kubernetes deployments, we are actually going to remove a lot of the other things that's previously used. And we're going to use Kubernetes natively by using its ingress, which can actually do the microservices routing, right, between the URIs to the backend services directly, okay? So for example, if I go and create a new directory here, I'm gonna zoom in, KS demo right here, okay? So one of the things that we can do is, of course, say JHipster Kubernetes, right? And it's going to ask you a series of questions. I have the couple of microservices created already, so I'm going to select them, right? And then it's going to ask me if I want to deploy elk or something else. For now, I'm just gonna say no. And it asks you a bunch of the default questions where I wanna push my container, what command do I wanna do the push, and so on and so forth. If you created a service with no service discovery, and if you want Kubernetes to do the routing for you, then you just create an ingress to actually do this, right? So if you create an ingress, what we're going to generate is this gateway ingress configuration file. And if we look into it, not only does it have, say, virtual hosting, if you have multiple applications you might want to host on the same endpoint, but in the backend here, for the ingress definition, for the default URLs, everything else like the JavaScript and everything is going to go to the gateway service, for example. And for the two microservices that should be in the past routed by Zool, in this case, we can actually route it directly using ingress by using the URL mapping here. Okay, so if I deploy this ingress, when you go to /microservice1/API, the ingress will actually route this directly to the backend services and do the load balancing for you. So that is pretty cool. So we are able to, if you generate without service discovery, then we are able to not having to use the JHipster registry, no Zool either. I know some people ran into issues with Zool in the past. No historics in that case, and also no ribbon because there's no service discovery anymore. We just use DNS names to do the lookup, and Kubernetes will do the L4 load balancing for us. However, it is a network load balancer. So what that means is every time you make a request, it's going to be pinged to the same network, the same backend that you previously connected to, right? Because it load balances per connection, but not per request. And in addition, in a vanilla Kubernetes deployment, when you connect to a service that way, there is no guarantees in terms of reliability. There's no resiliency when you make that call. So for example, if the network has issues, and without historics, then there is no retries, right? There's no circuit breaking in that case. And every call will just be made and maybe it will fail and it's going to propagate all the way back to the front end. So to alleviate that issue, right, there's something new that's been open source recently, which is ESTL, the service mesh. What that is that it will layer on top of Kubernetes today to create basically this mesh of fabric or whatever, this virtual thing that will magically take care of some of these issues for you. So if you deploy the same application now into the ESTL service mesh, what the mesh can do is, for example, it will deploy Zipkin and Prometheus and Grafana for you automatically. But more importantly, it can actually apply retries and circuit breaking directly to your application without you actually having to provide those client libraries in your application, right? We can also do load balancing, traffic splitting between different versions of the application. And the best part is mutual TLS connections between different services without you actually have to implement mutual TLS in Java, which is, wow, how did we actually do that? So behind the scenes, how many people here heard about ESTL Service Mesh before? About half of you. Oh, very cool. So behind the scenes, what we do is to deploy a proxy, a little proxy that will live alongside of your application within Kubernetes. So every instance that you have, we will have a proxy running right next to it. And behind the scenes, we'll set up interceptors where we actually intercept all of the connections, and we will intercept your microservices calls without you having to configure anything additional, right? So every time you make a call, it will be intercepted by ESTL Service Mesh by the proxy, and the proxy itself can apply some of these retry logics, the circuit breaking logic, the load balancing logic. And as Matt Rabel put it, I was speaking at his Denver Jog a couple months ago. He said that he coined this phrase, this is like aspect-oriented programming for microservices, right? Because we use AOP in Java, but that just still works with Java. But we can also do AOP with just microservices as a whole. And with ESTL Service Mesh, this can work for different languages as well, okay? So let me just show you very quickly before we move on to the App Engine stuff. If you want to learn more about ESTL, just go to my page and you can find video and sample code and a few other things if you like. So right now I have created just a couple of deployments for Kubernetes, right? I can go back to the generator. I'm going to go back to the JHipster Kubernetes generator. I'm going to choose the same options as well. Okay, and everything's default, default, default. Now here's the important part. This was actually contributed by Srinivas Vasu, who actually created the second portion of this Istio support, which is actually adding all of these prompts and generate the right files. So here we can just say, well, if I want to use Istio, how do I want to configure the proxy? Now, typically I will have a Kubernetes cluster that can automatically create the proxy instances for you, so you don't have to do anything special, right? So I'm gonna say that it's being installed. And then if you want to have the retry logic or the circuit breaking rules, then you say, I want to generate the Istio route files. And you also have to use ingress as well, and so on and so forth. And I'm just gonna say yes to everything. Yes, yes, yes. And what that is going to do is that in addition to all the regular Kubernetes files that's going to generate, it's also going to generate the routing rules for Istio. So if I open up the route rule, this is generated for Istio 0.7. And if I look at it, I can actually see that there are specific configurations for this particular service, and I can set up the retry rules globally. So anybody who's trying to use this service, they will be having this retry rules applied automatically, okay? So you can actually manage all of your microservices potentially through declaration of YAML files, all right? I can, of course, deploy it if I want to, but because of the time, I'm just gonna show you what that may look like. So if I get down the ingress, there we go. If I describe the ingress, it's going to give me not only the IP address, but also the routing rules. So this is just straight up Kubernetes. You can use ingress just within regular Kubernetes, and Istio just adds on top of that, right? So I can hopefully go to this thing right here, which I just did before the talk. Now, if I were to log in, all of these things are served by the gateway because the gateway has the front end. But once I logged in, if I go to see the entities, all of these entities are served by the backend instances. And these backend instances are just being routed directly by the ingress controller. Now, on different cloud environments, like on Google, you would get a real Google Cloud HTTP load balancer. In another web services cloud, I don't know what that stands for, you get their load balancer, right? But if you're running locally, then you can use Nginx instead, okay? So what that means is every time I go to ms1/API, say people, this is not going to work because I'm not authorized, but this is just routed directly via the ingress and not the gateway application, okay? So that's a very quick update on the Kubernetes generator. A lot of work was put into it. Again, there were two parts to the PR, and I have to say, Srinivas really did a wonderful job, and I really thank him for contributing to majority of this patch. Okay, there are definitely more things we like to do, but your help will be absolutely wonderful. We want to update it to Istio 0.8, which has a slightly different ways to create these rules. And then Istio also provisions Zipkin or Jaeger out of the box. We just want to use those out of the box as well. So there are a few other things we like to do to enhance the Istio support. This is just the initial support that we added. All right. And that was very quick, and hopefully you'll give it a try. And the second thing that we also created just recently is the generator for Google App Engine.
Yes. So in fact, it was checked in yesterday.
Merged yesterday.
Merged yesterday, so it's brand new. And in fact, we didn't know about it, so it might work or not. I tried it today, but
it works.
So yeah, so App Engine, who knows about App Engine? No, yes, it's ancient, old. Nobody uses it anymore, And yeah, we launched it 10 years ago. 10 years. I mean, internet is massively long, and it's still very popular and active. It's providing most of the revenue for Google Cloud Platform still, even though Kubernetes and GKE and new products are growing a lot, but App Engine is still growing. So we launched Java 8 last year after 4 years of trying to upgrade from Java 7. And the reason why we spent that much time was the security sandbox has been completely redone. And it has been recently leaked that the new security sandbox that Java 8 runtime is using for App Engine is the gvisor product that we moved to open source a month ago. So this is the reason why it took us that long, because we could not trust anymore the Java security sandbox. We had to expand it beyond the JVM. So finally, we can run Spring Boot JHipster out of the box. Before we had the old security sandbox that many limitations. Now all those limitations are gone. But it's still the same product, I mean, same App Engine product without the limitations. Same free tier, automatic, manual, basic scaling, everything is included. So centralized logging with the admin console, remote debugging, very cool. Maybe we can show it on JHipster. You can set breakpoint in your deployed app. Monitoring, security scanning, traffic splitting when you upgrade your version. Everything is baked in. All the JavaScript static files are served not by the JVM, but by a static content provider from Google. So a side effect of this is maybe the page is loading way before that the JVM is loading, so you might have some UX issue there. So we're gonna demo it. So you create JHipster application. So do you have one already, or?
Yeah.
Okay. So if you have one, then you can apply the GAE, I mean Google App Engine sub generator, that will add the extra configuration file you need to deploy to App Engine. So the generator is connected to the Cloud SDK, so you need to install the Google Cloud SDK, and the Cloud SDK gives us the APIs that validates all the entry that you can put in this generator. So for example, the default project ID for this Cloud SDK installation is whatever, Wise Coyote 827. Okay, so you select it. It will tell you in which region is currently running on US Central. You cannot change it for now, but
if it's a new project, you get to select.
Exactly. So you can create if it's a new project, you can select where this project will run. Then it will ask you which service name you want to use. So an App Engine application is a collection of many services. So we'll pick the second one, Monolith. Now this is the interesting part of the configuration. You define the instant classes, F like front end or B like back ends, and the scaling type. So we're gonna go with a B8, a big one, big freaking manual scaling, 1 gigabyte of memory.
So what's the difference between these different scalings?
Well, yeah, I mean, there is a web page, but there is automatic scaling. Your requests are killed if they are not served in 60 seconds. For manual or basic scaling, the request can last 24 hours, for example. So this is one of the main difference. And then F1B, I mean, F or B are front end or back end, so B are a little bit bigger and mostly manual scaling. So booted for you when you deploy. So let's do manual scaling, and we'll pick two instances. Yeah. Why not?
So for basic scaling, you can pick the minimum instance and the maximum instance. For manual scaling, you just pick exactly how many instances you want. For automatically scaling, you don't specify anything. It will just determine how many instances you need based on the load. Okay, so let's do two. Okay.
Yes. So next is, well, you need a database, and good luck. We have Cloud SQL available for all the App Engine and Cloud projects. So the Cloud SDK here is introspecting your project and find two instances. So let's pick the first one, which has been created before, but you could create it with the generator as well, with all the validation. You type the username, password. We're going to try if the connection is working right there. Yeah, and then for an instance, you have many databases, so we're going to pick one that we created before, or you can create one here.
You want to create a new one?
No. No, because liquid-based
really?
take too much time. Yeah. Okay, so you're done. So basically, everything you wrote here all the information is stored in most of the configuration file is App Engine web.xml that you can edit if you want. And then we added a few artifacts in the pom.xml, and then a profile for App Engine. So we have the prod application prod GAE profile.
So just to show the So these files are just generated for you. We add the plugin directly to your POM, so then you can just deploy it. Okay, you think this will deploy?
So let's try it. Yeah. So I think you emit the command line to deploy. So we use the App Engine Maven plugin, and that will compile everything, package the application, and upload all the files in the cloud, and only upload the file that changed compared to the previous deployment. So if you change one Java file, for example, and nothing in JavaScript, you will only upload this .class, assuming you do not jar the classes in your webinf area. So I don't know. I mean, still JHipster doing its thing, so I don't know what it's doing here, but
yeah, this does take. I don't know what step this step actually is doing, to be honest, but this is usually the longest step. But it is definitely not from our plugin.
Not yet.
Not yet.
So usually an App Engine classic, an App Engine standard deployment takes between 30 seconds to 1 minute. So it's pretty fast.
Yeah.
Okay, so now we are trying to see if you have GSPs. We don't have, we still have some stack trace, but don't worry about that. It's still beta. This is working.
All stack traces.
Ignore stack traces. We're going to work on them in the next months.
Oh, look.
Yeah, so it was only 6 files modified compared to the previous deployment on the same app. So yeah, optimal deployment. As opposed to a fat jar where, the fat jar you have to redeploy the jar. But anyway, so done, okay?
Yeah.
So now you can, let's try it.
So we can go to the URL. So
yeah, so as you see, the JavaScript files are served immediately.
Yeah. This is done before your application even starts, because this is packaged as a war. We know where the static files are. So the static files are automatically loaded into a CDN, basically, or static content serving. So your application can actually be viewed before the backend actually starts. But if we go and trigger a backend request, if you have automatically scaling, then it's going to start the instance for you on demand, basically. And if nobody uses the app, it will shut down the instances automatically. Yeah. Okay.
But so the first time it can take maybe 30 seconds to boot Spring Boot and to load the app.
Yeah. Okay. Yeah. So this case it actually worked partially because we're doing manual scaling. So behind the scenes, as soon as we deploy the app, we also just start the instances for you behind the scenes. So there's no delay in terms of waiting for the instance to start, because it started automatically. Because we said we needed 2 instances. If it was automatically scaling, then you might actually experience a little delay because you need to wait for the instance to start before the response can be retrieved.
So it's working, it's amazing. So let's look at the admin console if we have time now. No?
Yeah, definitely. So we can go ahead and see a few extra things that you can do once you deploy into App Engine. Okay. So as you notice, we didn't really deploy any of the elk stack, right? There's no Zipkin, there's no centralized logger and stuff like that. But you do get all of the things out of the box with App Engine. So for example, we can go ahead and see the dashboard, or we can see our running services. So in this case, I have my version 1, and I have 2 instances running. That's how many we said that we wanted, right? We can set up security scanning rules if you want to. So this will actually automatically crawl your application and try to break it, I suppose. But what is really cool, though, is without any of the things that we need to deploy separately, the logs are already centralized in the console already. So here I can actually go into my logger viewer, and I can just go and find the log I want to see. I can see which App Engine app specifically I want to look at. So I deploy Monolith, and I can see the request log, and for every request, we can actually browse in and see the log associated with that particular request. So there's automatically request log grouping. In addition, if you want to see how long the requests are taking, so again, without having to deploy anything extra, you have trace built in automatically. So we can actually go and see, for example, which servers you want to see the traces for. So I'm going to say Monolith. And here we can see multiple requests that's been made before. So for example, this request took 1 second. You can see very clearly that took 1 second. And so on and so forth. So maybe let me find a request that has, this one. So this request is going to API events. We can see that it took 191 milliseconds, right? But what is really cool is all the log that was produced with this request, you can click right here. You can see all the logs associated with this particular request as well. And you can go view it in detail and so on and so forth. Yeah, which is pretty neat.
Can you debug it in 1 minute or not?
Yeah, definitely. So one of my favorite thing here, well, first of all, because we have all the logs, we can actually detect the exceptions automatically. So who here actually go to the production log and say, I wonder what exceptions I have today? Anyone? Yeah, there you go. You're doing it the right way. However, here, because we have the log, we will notify you when you actually have new exceptions that we never seen before, or you can actually see that we have a lot of liquid-based exceptions in this case, which I don't know why. And then finally, this is my favorite part, is the debugging. So again, this is just a simple deployment. You do the Maven app engine deploy. You deploy into this environment. If you have the source code on GitHub that's accessible, or if you mirror it here, we can actually download the source code. But I don't have it on GitHub right now. So what I'm going to do, I'm going to just upload the source code, right? So here we have the monolith, which I have generated. Here we have the main. I'm just going to upload just the Java files, for example. So I'm going to upload it, 288 files, sure. So it uploaded the files. That was way too quick. Okay, that's a little dangerous. But once we have the file, we can actually go and browse the application, the source code. So for example, if I actually go and find the event resource, okay, which is right here, event resource, I can see the source code. Again, if you have GitHub, this will be done automatically. But if you go and find, oh, I don't know which one is a good one. Let me go to post. Yeah, this one. So if there's anything going wrong with your app, there are two things we can do. Number one, you can debug it. So you can say if you forgot the log messages, like I wonder why I was here, I can add a log here. I can say I'm here. Okay, pretty cool. And anytime that somebody comes through this line of code, it will be printed into the log in the centralized logger. If I want to say, I wonder what if I was here, I can say, this is how we debug, right, in JavaScript. I'm here now. I'm just kidding. But I'm just saying that if you do need it, yeah, you can. This is how we Java developers troubleshoot, right? We can do better. How many people here would love to like put a breakpoint in your production code? Anyone? Yeah, stopping the world. Yeah. But we can actually do it.
Assuming you have 100,000 JVMs running, like Snapshot, for example.
Yeah. So we can actually take a snapshot of the running application for a particular line of code, like say right here, and maybe right here. If somebody goes to the application, I'm gonna just go to here. I'm going to create a new event. We already got JHipster conf. I got GCP next. I don't know what's next. Let me say JHipster conf 2019. Yeah, something like that. New York. Yeah, in New York. Ah, there we go. Yeah. So, anyways, I'm gonna pick a random date here. I'm gonna save. Now, this is going to trigger the application to go through this line of code. Not only did it actually print the logs, it also captured the stack. I can actually see, for example, right here, what actually went into the event, for example. And there it is. There's the name, and there's the event date. Okay. That's pretty cool, right? And you get this out of the box from Google App Engine. Very nice. Yeah. Yeah. Kudos to Ludo. Yeah. So I think that's pretty much all we have, right? We have these backup slides just in case nothing worked. Yeah. Anyways, the reason we're here is that we do have two PRs and also issues that's there. If you can, please contribute, give us any feedback, and try this out. All right. Thank you so much.